Hello everyone, welcome to the video lecture series of Basic Electrical and Electronics Engineering. In this session, we are going to discuss the Ohm's Law. The Ohm's Law relates the electric current, voltage and resistance. How they are related to each other is stated by Ohm's Law. A law stating that electric current is proportional to the voltage and inversely proportional to the resistance. This is the relation between electric current, voltage and resistance. I is equal to V upon R, where I is the electric current, V is the voltage and R is the resistance. This diagram shows the three triangles which are used to remember this relation I is equal to V upon R, where V is written at the top and I and R written at the bottom. If you want to calculate V will be the product of these two I into R. If you want to calculate this I, then it will be the ratio of V upon R. If you want to calculate the R, then R will be the ratio of voltage and current. In this way, you can remember this relation I is equal to V upon R, or the relation between current, voltage and resistance, which is stated by the Ohm's law. Let's take one numerical based on the learned topics in the previous and this lecture. The question is, calculate the total current flowing through the circuit. This is the circuit given where 4 resistances are connected in this manner and 12 volt voltage source is given, and we have to calculate this total current IT. How it can be calculated? This current can be calculated with the help of Ohm's law, that says that I is equal to voltage upon resistors. This I, current IT, equals to voltage V upon total resistance of the circuit RT. Here we already know the voltage, that is 12 volt, but we don't know the total resistance offered by the circuit. This will be the resistance. RT is the resistance of this total portion. Okay, if you calculate this RT, then automatically we can calculate this IT with the help of this formula. Let's do one by one. The step 1 is R2 and R3 are in series. So R23, the combination or equivalent of R2 and R3 will be R23, named as R23 equals to R2 plus R3 is equal to 8 plus 4, 12 ohm. Okay, this is the resistances. R2 and R3 are connected in series. The equivalent will be 8 plus 4 is equal to 12 ohm. Okay, this will be the 12 ohm. And the step 2 is this R23, which is 12 ohm, and R4 are in parallel to each other. Where is R23? This is the equivalent of R2 and 3, R23, and this is R4. These two are in parallel with each other. So when the resistances are connected in parallel, we calculate with the help of this formula 1 upon R equivalent, which is the equivalent of 2, 3 and 4. So R2, 3, 4 equals to 1 upon R23, which is the first resistance, and plus 1 upon R4, which is the second resistance in parallel. R23 is calculated as 12 ohm and R4 is given as 12 ohm. So 1 upon 12 plus 1 upon 12 will be 6 ohm. Now this R2, 3, 4 and R1 are in series. Let's see the diagram. This R2, 3, 4 and this R1 are in series. So when they are connected in series, can be added directly. So R total equals to R2, 3, 4 plus R1 equals to R2, 3, 4. We have calculated that 6 ohm and R1 is given 6 ohm. So 6 plus 6 is equal to 12 ohm. This is the total resistance of the circuit. This is the total resistance of the circuit we have calculated, and we have got the value of 12 ohm. So the last step is calculate the total current can be calculated with the help of this formula V upon RT. Voltage is given 12 ohm and RT is also 12. So 12 upon 12 is equal to 1 ampere. This is the required answer. This is the required current flowing through the given circuit. The next topic is electrical work, power and energy. The electrical work is the work done to transfer the electrical charge from one point to the another point. See this figure. In this figure, this circle indicates that charge. Charge is measured in coulombs. So this is the charge of Q coulombs, and we have to transfer this charge from A point to B point. To transfer this electrical charge from A point to B point, how much work done is required, which is called as electrical work, and it is measured in coulombs. Then electrical power is the product of voltage and current. Power P denoted by P, and it is the product of voltage and current and measured in watt. The electrical energy is the product of power and time. So E is equal to V into I into T kWh. The electrical energy is measured in watt hour or kilowatt hour. 1 kilowatt hour equals to 1000 watt hour. Okay. Let's solve one numerical based on this topic. The question is, a furnace takes a current of 10 ampere from a 200 volt DC supply for 8 hours and calculate the energy consumed in kWh. This is the solution. The given data voltage is given 200 volt, the current is given as 10 ampere, and T is equal to 8 hours. The time period is 8 hours. We have to calculate here energy consumed in kWh, but we know that energy is the product of power, electrical power into time. So first calculate the electrical power. Electrical power P is equal to voltage into current. So 200 into 10 will be 2000 watt because power is measured in the watt. The electrical energy is equal to power into time. So power is 2000 watt. We have calculated here, and into T time period is given is 8. So 16,000 watt hour. We have asked here to calculate the energy consumed in kWh. So converting the 16,000 watt hour to 16 kWh, because 1 kWh equals to 1000 watt hour. This is the required energy which is consumed by this furnace. Okay. In this way, the energy consumption is calculated, and our meters, energy meters, also have the reading in terms of kWh, and according to the monthly energy consumption, we get the energy bill or electricity bill at the end of the month. Okay. This is all about the basic terms related to electrical circuits. In the next session, we are going to discuss the basic terms related to magnetic circuit. Till then, stay tuned and keep learning. Thank you.